Hello there fellas. In the previous video we have discussed about the spherical mirror and the different things and the terminologies involved in that particular process when light interacts with the mirror. Now what we'll be doing is we'll be studying about the important and basic aspects of the process of forming an image in the case of the spherical mirror. Now we have already learned that when we have to form an image, or if we have to see an image, then the reflected rays have to meet at some or the other point, right? So in the case of plane mirrors, as we have learned, we have seen that the reflected rays diverge from a particular point, but they do not actually meet at a point. So what did we do? We trace the rays back in the direction opposite to their propagation, and then we have seen that the image is formed behind the plane mirror, and that is a virtual image which cannot be caught on the screen. So we'll be doing the same thing for the spherical mirrors also. And what is that? We'll be placing the object in front of the mirror, and whatever the light rays that are emitting from the object, they propagate and they incident on the spherical mirror and they get reflected back. If they're diverging, then we trace the rays back in the opposite direction of the propagation, and then we'll see where the image or the reflected rays are appearing to meet behind the mirror. And if they're actually meeting after reflection, then that is the point where the image is actually formed, and that image is a real image, as we have learned in our previous videos. So to find the image or the point of intersection of the reflected rays, we need just two incident rays, where these incident rays after reflection pass through the known points. And when I say known points, as we have discussed in the previous video, what are the known points? One is the pole, which is the center of the spherical mirror. One is the focus, which is half of the radius of curvature. And the center of curvature, which acts as the center of the sphere in which the reflecting mirror is a part of it. So the first one is the focus, right? One of the point is the focus, where the reflected ray has to pass through the focus. So if the incident ray is traveling parallel to the principal axis, then it passes through the focus. This is the first point that we have to know. And the second point is that if we incident the light ray normal to the spherical mirror or perpendicular to the spherical mirror, then the incident ray is making an angle of 0 degrees with the normal. Now what happens when the incident ray is 0 degrees with the normal? Right, the reflected ray also has 0 degree angle, right? That's what we have learned from the laws of reflection. Angle of incidence is equal to angle of reflection. So this ray reflects in the same path but in the opposite direction as the incident ray. So this is how it looks. Now as the radius of curvature forms as the normal to the spherical mirror, then if the ray is incidenting onto the spherical mirror along the direction of the radius of curvature, then it passes through the center of curvature, because from any direction, whatever the incident ray is making an angle of 0 degrees with the normal, then it has to pass through the center of curvature. So this gives our second point, that is the center of curvature. Alright, now enough with the theory. Now let's get some action by doing some real geometrical analysis, and then we can form the image of any object. Let us consider a point object which is placed on the principal axis, as you can see, and here we have the mirror, right, which is a concave mirror which is curved inside. And as you can see, when the rays are incidenting through the principal axis, let's say one ray is going through the principal axis and it is incidenting on the spherical mirror perpendicularly. Now what happens when a ray incidents perpendicular to a mirror? It retraces its path, right? So here also the ray retraces its path and goes in the opposite direction of the incident ray. Now the other ray that we have talked about, we take two rays, right? One we have taken parallel to the principal axis, and the other ray, what we'll be doing is we'll be randomly incidenting on the spherical mirror. Now that is not exactly normal to the spherical mirror, but it is incidenting at some angle. Now using laws of reflection, we can say that the angle of incidence is equal to the angle of reflection. So let's say if it is incidenting at some point, then it reflects back and it is cutting the principal axis at a particular point which is between the center of curvature and the focus. Now as you can see, as you have placed the object on the principal axis but behind the center of curvature, the image is formed between the center of curvature and the focus. So this is the intersection of the two rays, that is, one is along the principal axis and the other one is just the reflection of the incident ray, which is the point A on the spherical mirror. So this, let's say this point of intersection is I. So this point I is the image of the object O, which is placed behind the center of curvature. So as you can see, when we have placed the object on the principal axis, then the image is also formed on the principal axis itself. So this was the case where the point object is placed on the principal axis. Now let's take a case where the point object is placed somewhere else. Why don't we just put it above the principal axis and see what happens to that object and how the image is formed. So let's do that. So this is the principal axis, as you can see, and here let's place the spherical mirror or the concave mirror as it is curved inside. Now let's place the object here, which is above the principal axis. Now there are two rays that are coming out of the object. One is parallel to the principal axis, and we have said if we take 2 points so that the rays pass through those 2 known points. Okay, so here we are passing the ray which is parallel to the principal axis, and the other ray is passing through the center of curvature. Now we know that whenever an incident ray is propagating in the parallel direction to the principal axis, then it passes through the focus, right? So as you can see, it is passing through the focus. Now the other one, which is passing through the center of curvature, as you know, whenever it incidents normally on the spherical mirror, it reflects back in the same path, right? So as you can see, it is just passing through the center of curvature back in the same path but in the opposite direction. So this is the point of intersection, that is point I is the point of intersection of the two rays. So if we compare the two cases, where in the first one we place the object on the principal axis and the image is also formed on the principal axis, but it is formed between the center of curvature and the focus. On the other hand, when we place the object above the principal axis, then the image is formed below the principal axis, but it is formed between the center of curvature and the focus. Now with these two cases, what is the common thing that you can find? The object that is placed is behind the center of curvature, and the image that is formed is between the center of curvature and the focus. So this is the important point that you have to note. Until now we have discussed about point objects which are 0-dimensional, right? Now let's discuss about the extended objects which are 1-dimensional. Now for simplicity, we'll be taking a linear object. A linear object is nothing but a simple line placed perpendicularly on the principal axis. Now don't get startled that now it's a linear object and we have to consider a lot of rays coming out of this object and we have to form the image of those points. That is not the case at all. Don't worry about it. We'll be using the same rules that we have used in our earlier cases. What is that? Well, if you take a particular point, then we have to take just 2 rays that are coming out of that point and we'll be forming the image accordingly. Now here it's a continuous object, right? So one single line. Then what points do we consider to form an image of this particular linear object? How do we do that? Well, it's very simple. See, it's a linear object placed perpendicularly on the principal axis, right? So we'll be forming the image of the top point and the bottom point. And those 2 points will be forming an image somewhere, right? Whether it's front of the mirror or behind the mirror, somewhere they'll be forming. And what we'll be doing is we'll be drawing a line, or we'll be connecting those 2 points to form a line. And that line is the image of this particular extended object. So that simple it is. So let's take that linear object and place it perpendicularly on the principal axis. So this is that object. Now point A is on the principal axis and point B is above the principal axis. Now for a change, we have taken the convex mirror, because in the beginning we have told you that when the rays are diverging, then they must be coming from a particular point, or they might be appearing they are coming from a particular point which is behind the mirror. So this rays diverge from the convex mirror, and what we have to do is we have to form an image. And for us to form an image, we have to retrace the path of those reflected rays in the opposite direction of their propagation and see where it appears to be coming from. And that is the reason we have taken a convex mirror. Now we'll be dealing with concave and convex mirrors separately in the next video. But for now, let's just consider this as the mirror that is required for us to discuss this particular concept. Alright, let's start with image formation now. So as you can see, this is the linear object AB, and as you can see, this is the point object B, which is above the principal axis. Now as we have discussed earlier, we'll first see what the point object B forms an image, whether it is in front of the mirror or behind the mirror. Let's see that. So for that, what we have to do? We have to take two rays which are emanating from this point object B. One is parallel to the principal axis, one is through the center of curvature. So as you can see, this is the parallel ray and it is reflecting in some other direction. But if you retrace it back, then it is coming from the focal point which is behind the convex mirror. So this is the first ray where it is meeting at the focal point. Now the other ray is the ray which is passing through the center of curvature or along the direction of the center of curvature. So as you can see, this is the direction of the center of curvature and the ray is also propagating in this direction. So here it is interacting with the mirror and then it is reflecting back in the same path. But if you retrace the path, then it is coming along the direction of the center of curvature. So it is pointing out to the center of curvature. Now where are the two rays meeting? They are meeting between the point pole and the focus, right? That is the point where the intersection of the two rays is happening. Now let's form an image of the other point which is on the principal axis, that is point A. So let's take two rays that are coming out of it. One is parallel to the principal axis and the other one is just a ray which is incidenting onto the convex mirror. So this ray which is parallel to the principal axis, it reflects back and it appears to be coming from the other side of the convex mirror. Now the second ray which is just incidenting onto the convex mirror, it reflects and then if we retrace the path, then it forms an image between the pole and the focus. So this is the other point of the point A. So let's just join these 2 points. That is the image formed by the point object B, that is B dash, and the image formed by the point object A, that is A dash. So we have an image of the linear object AB as A dash B dash. Alright, so we are now fully equipped with all the knowledge that we have to know. In the next video, we'll be using some spherical mirrors, that is concave and convex mirrors, and see how we have to form an image depending upon the different cases of the placement of the objects. For now, let's summarize what we have learned. So the first thing that we have learned is the incident rays which are parallel to the principal axis, they converge to the focal point or appear to diverge from the focal point. Rays incidenting along the normal of the spherical mirror reflect back in the same path. Any ray that incidents on the spherical mirror follows laws of reflection and the image has to be formed accordingly. The image of a point object is formed by the intersection of the reflected rays.